All right, ecologic studies. That's going to be the focus of this video and going over a few examples. So the first example we want to go over is going to be this Gapminder example where we're looking at the smoking prevalence for countries with life expectancies over 60. So smoking prevalence for all ages over 15. And we're going to put this thing into motion. We can see the life expectancies go up, and we also see this trend that exists where countries that smoke the least, like Nigeria, Niger, Ghana, Mali, Malawi, Zimbabwe, they have some of the lowest life expectancies in the world. And the countries that smoke the most, like France, Cyprus, Greece, Chile, the Czech Republic, Spain, they have some of the highest life expectancies. So, can we conclude that by smoking a lot increases your life expectancy? Well, we know that that doesn't make sense based upon previous studies, case control studies, cohort studies, cross-sectional studies that have been done on people who have pretty horrible diseases, and they ask them about their smoking history. So this is an example of what we call the ecologic fallacy, where something exists at the population level, but it's not true maybe at the country level or the county level, or if you even go down further to the individual level. So what we're going to do next is we're going to look at some U.S. data. And you've already done some of this through your assignment. So the first thing I've got from County Health Rankings. So there's a website called County Health Rankings and Roadmaps. This is where they come from, and it's a cool little tool. You can do a lot of good stuff on it. You can learn a lot about the health of your community and how things compare. I just randomly clicked on Boone County, West Virginia, home of Jesco White. And on Boone County, you can see all this good information. You can download information from here for all the counties in the United States. That's where your assignment information, when you did your ecologic assignment, that's where that information was from. So I've got the data from County Health Facts pulled into the stat program into Stata, and it's for all the states and counties in the United States. And the things I'm going to pull up to look at first that may be of interest to you would be the life expectancy and percent smoking, which you guys already did this. And we see that in the United States, for the percentage of the citizens in a county that smoke, as that number goes up, life expectancy goes down. And it's a fairly strong relationship. These counties have the highest life expectancies. It's actually kind of like, here's the sweet spot, maybe on income. Life expectancy, smoking, and income have a lot of interrelationships at the county level. But overall, though, we see counties that smoke the most tend to have the lowest life expectancies. Does that mean that smoking a lot causes you to have a lower life expectancy? Well, not based off of these data. These data may suggest that, but other studies had to have been done at the individual level. You cannot use ecologic data or county level data to make inferences about things that happen at lower levels, at the individual level. You can hypothesize and do future studies. All right, getting more into some other examples. Ecologic data. So that one was kind of intuitive, right? We already knew this one. More smoking, lower life expectancy. But let's look at another one. I've got lower life expectancies with less income. You make less money, you live less. That's what you might think at the individual level. Is that true? You need studies at the individual level to prove that. But at the county level, there is an association at the county level that the counties that make the least amount of money on average, the median household income for the counties in the United States is the lowest life expectancies. As we get wealthier, life expectancies go up. But there's kind of this sweet spot here around $75,000 where life expectancies for these counties seem to be the highest. All right, here's another one. County level, this is one of the more interesting ones that some people can't figure out, but I think I figured it out. This is the life expectancy by the percentage of the population that, I put percent booze, but this is the percentage of the population that engages in binge drinking. So the counties that have nearly 30% of their people binge drinking, those counties have some of the higher life expectancies. And the optimal life expectancy at the county level is somewhere in the 20 to 25%, meaning 1 in 4 to 1 in 5 of the people in the county report binge drinking at least once per week. So that's a lot, you'd think. It doesn't necessarily make sense. We can even look at it on the quartile, where I've broken them down into the lowest to the highest by 4 quartiles. We'll graph the box over booze. Here are our lowest 25 percentile and our highest 25 percentile. The upper quartile of binge drinking counties in the United States has the highest life expectancy. The counties that binge drink the least have the lowest life expectancies. If we were to look at the data on why, I need to sort that, by the way. So we'll go ahead and sort it out with not percent booze. Let's see. I've got it on here somewhere. We got to sort by percent booze. I'll just type it in. Sort percent booze. Done. We look at our data editor. Where are these counties at that are the booze drinking counties? These ones drink the least. You know, McDowell County got one of the lowest life expectancies in the country, and they report binge drinking the least. These counties down here at the bottom drink the most. It's like half the state of Wisconsin. So you can go check out my boy Charlie Barron's and learn all about the Manitowoc Minute. They like to drink in Wisconsin. The whole state does. Life expectancies are better in Wisconsin. The income levels are better. They don't smoke as much. Better educational attainment rates. But most of the counties that drink the most are in Wisconsin, and the life expectancies are mostly in the 80s. Another factor could be the college or university effect. Counties that binge drink a lot generally have a younger population that tends to be there to drink, and then they're transient and they leave. Communities that have universities have more binge drinking. Those communities often get more state money. Those communities often have higher wages. Those communities often have higher income and higher educational attainment. I don't know those things for sure. I just know the associations exist at the population level. So that's kind of getting at the ecologic fallacy. So just because something looks like it's true at a population level does not make it true at the individual level. Other studies like case control, cross-sectional, or cohort, particularly case control and cohort would be the better ones, to then verify or test hypotheses about things you may observe at the county or ecologic level. There are a lot of really interesting studies that are out there that have been done on coal mining and adverse health effects by a guy named Michael Hendricks. I just typed it in. It says Hendricks and coal. All kinds of studies on county level data and health effects. I think he's at Indiana University now. He used to be at epidemiologist at West Virginia University. But he does a lot of these where he shows these increased risk in Appalachian counties. Most of those studies are ecologic in nature, but ecologic studies might be the best that you got. It might be all you have to work with. All you got is population data and county level coal data. Maybe that's all you got to work with, and you're just showing the relationship and then recommending future studies to be done. So hopefully this has been helpful in understanding how ecologic studies are done. It's important to realize that the ecologic fallacy exists. The same ecologic fallacy exists with respect to why people or some people think that vaccines are like associated with autism. I got another video that I might show you guys from my stat classes that I show about correlation not being causation, that looks at factors that are time dependent and how things over time may make things look like they're associated. For example, in the Chinese studies, right now, when the outbreak started on COVID-19, as things start warming up, case numbers start warming up. Is it because of the temperature? Is it because of something about the virus? Or is it the fact that as the disease is spreading, it was also getting warmer at that same time as a function of time? So correlational studies are good for hypothesis generation, but that's about where we should draw the lines with them. We should not apply population level correlational data to individuals. So I hope the sermon here has been effective. This is important to know for your quizzes and your exams. So if you have any questions or anything about correlational studies, I'm not strongly against them. I think that they're great, but I also recognize their weaknesses. So if you have questions, feel free to email me, jason.marion@eku.edu, and I hope the rest of your epidemiology class is going well.